Welcome to my YouTube channel. Today we shall be taking Dalton's law of partial pressure class 2. Dalton's law of partial pressure class 2. So, and it's gonna be basically on solving the possible jam and Weac word questions. So that's what we're gonna be doing today. And please, if you have not subscribed to this channel, you can quickly go to the subscription box and click on it as we keep updating you on the possible jam and Weac questions. So this question says that when 500 cm cube of oxygen was collected over water, that is 500 cm cube oxygen was collected over water at 30 degrees Celsius and 752 millimeter mercury pressure. What is the volume of dry oxygen at STP? That is standard temperature and pressure. Then in bracket, vapor pressure of dry oxygen at STP is what? Is 32 millimeter what? Mercury. So before you solve this, the question most persons make is that they just assume this is V1, they derive their V2, T1, blah, and use the general gas equation. So if you go ahead using the general gas equation, you are going to get it wrong. Though we are using the general gas equation to calculate our volume, but first and foremost, you must go to our Dalton's law of partial pressure class 1 to check the possible formulas we're able to derive, that is in order to calculate problems when it has to do with what? Dalton's law of partial pressure. And you can see that we establish a relationship that for you to be able to solve questions on this Dalton's law of partial pressure, you must at least be conversant with about 5 to 6 formulas. 5 to 6 formulas. So if you check our first video now, we discuss in details about this formula, and in one of the formula, we are using 2 of the formulas to solve this, because sometimes in solving one formula can lead, you must like match 2 to 3 formulas for you to be able to arrive at your destination. So following this, let's bring our data so that we can forge ahead on the calculations. Now they say 500 cm3, so this is our volume. Let's assume this is V1, which is equals to what? 500 what? cm3. Oxygen was collected over water at this temperature, so this is T1, which is equals to what? 30 degrees Celsius. 30 degrees Celsius plus 273. So we have to convert this to standard, right? And 752 millimeter mercury pressure. Now this is our what? This is our total pressure. So this is P total, which is equals to what? 752 millimeter what? Mercury. 752 millimeter mercury. Now they say, what is the volume of dry oxygen at STP? What is the volume of dry oxygen at STP? Vapor pressure of dry oxygen at 30 degrees Celsius is equals to what? 32 millimeter what? Mercury. Now this is the vapor pressure of water. This is the vapor what? Pressure of water. So our VPW, vapor pressure of water, is equals to what? 32 millimeter what? Millimeter mercury. 32 what? Millimeter mercury. So this is our possible data. So can we go ahead to see how do we do this? Now for you to solve this, you cannot use the general gas equation there, right? What you are going to do, you must look for the pressure of the dry gas. You must look for what? The pressure of the dry gas. So if we want to do that now, let's try to get the pressure of the dry gas. So now there's a formula that says that P total is equals to P dry plus what? Water vapor pressure plus water vapor pressure. This is one of the formula we derive in our first class for Dalton's law of partial pressure. So please try and watch the class to have a clue on how to tackle problems when it has to do with what? Dalton's law of partial pressure. So looking at our data or parameters, you can see that our P total is equal to what? 752. P dry was not given, that's what we are looking for. Plus our water vapor pressure is what? Is 32. Is 32. So when you make P dry the subject of the formula, P what? Dry is going to give you 752 minus what? 32. 7 what? 52 minus 32. So if you try that, 752 minus what? 32 is going to give you 7 what? 720. So this is 700 and what? 20 millimeter what? Mercury. Millimeter mercury. So this will then be our what? Our P1. Are we following? This is our what? P1. So if I want to bring out this data very clear now, so this is the first step now. You get the P of the dry oxygen. So the pure P of the dry oxygen is like this, 700 and what? And 20. So now, if I want to bring out my possible data before I use my P1 is equals to what? 720 millimeter mercury. My P2 is equals to 760 what? Millimeter mercury. V1 is equals to 500 cm cube. So V2 is what we are looking for, right? Then T1 is equals to 30 plus 273, which is 303 Kelvin. So I have my T2 will be equals to what? 273 Kelvin. So if you have these data now, you should be able to what? To forge ahead and use your general gas equation. So by this we should be able to what? To calculate our volume. We should be able to what? To get our volume. Now looking at this now, some persons will ask that why is this one what? 760 and it was not given in the question. Now this is constant for pressure in millimeter mercury, and you can see that T2 was not given, but they say at STP, that is at standard temperature and pressure. So this at standard temperature and pressure in millimeter mercury, we have 760 millimeter mercury as our what? Pressure, and our T2 is what? 273 Kelvin. So we can now go ahead to use this formula that say P1 V1 over T1 is equals to what? P2 what? V2 over what? T2. P1 V1 over T1 is equals to what? P2 V2 over T2. So remember that we are what? We are calculating V2. So if you make V2 the subject of the formula, we'll have what? P1 V1 T2 over P2 over P2, then what? T1. So this is the formula we are going to use because we are looking for V2 from the formula, or what does what they ask us to calculate the volume. So if you make P2 the subject of the formula and you cross multiply, you have P1 V1 T2 all over what? P2 T1. So you can just go ahead and insert your values now, or your parameters. So therefore V2 will be equals to what is P1? P1 is equals to 720 times what is V1? 500 times what is T2? 27 what? 3. All over what is P2? 7 what? 60 times what is T1? 3 or what? 3. So can you see? You just insert your values here. So you now say 720, 7 what? 120 times 500 times what? 273 is equals to what? This is equal to what? 98280000, right? All over 760 times 303. This is 230280. So 230280. So this is our what? This is our V2. Our V2 is 9828000 over 230280. So let's divide this and see. So we have what? 9828000 divided by 230280. So this gives us V2, then is gonna be what? 42 what? 6 point what? Point 7 what? cm cube. 0.7 what? cm cube. 0.7 cm cube. So V2 is equals to what? V2 is equals to 426.7 what? cm cube. So that's the volume they asked us to calculate. So please make sure you subscribe. As I said, we'll continue with more questions on this on the next video.